Hello, welcome to a video on the product to sum and sum to product formulas. And these formulas are exactly what they sound like. They are things that take you from starting with a product and you're changing it to a sum. So we've got multiplication in between the trig functions here, and we're changing that to where there's a sum. Again, sum meaning plus or minus. A minus is like the sum of the opposite, adding a negative. So we start off with multiplication, we end up with either addition or subtraction. So what you have to do to use this formula is just match up what you have. We have sine times sine, so that's going to be this top guy right here. And we just plug in what everything is. Alpha is the thing in the first one, beta is the thing in the second one. And typically you just make the first one the bigger, like alpha is, the coefficient, if you will, of alpha is bigger than beta. And the reason why you want to do that is because when we subtract, we don't want to have to deal with changing these things from negatives to positives, using those even and odd properties to change them, which we could. It's not that big of a deal, but it would just save you a step if you just rearranged it to make it where the alpha is like the larger coefficient on the variable. Because it's multiplication, we can multiply in either order anyway. So what I'm going to do is plug in exactly what we see here. I got a 1/2 and then a bracket cosine, and then I'm going to subtract the two, alpha minus beta. So this is alpha, this is beta. Alpha is 8x minus 3x would be 5x. Alright, and then that's this whole thing taken care of. So now minus, and then another cosine. This time I add the two. Well, 8x plus 3x is 11x. And that's how that formula would work out there. We can't combine these. This is not going to be cosine of like negative 6x. These are inside the cosine, so we can't subtract these x terms. Okay, so that's it. That's how I would leave it. All right, and then for part B, let me switch to blue. For P, I've got a sine times a cosine, so that's this guy right here. And again, if this had been like a 6x or something, I would have switched it and made it this one and just switched the order. Okay, but I end up with a 1/2 sine alpha plus beta, so sine of 4x plus x would be 5x. All right, and this time it's a plus in the middle, so plus, and once again another sine, and this time it's alpha minus beta, so 4x minus x would be 3x. All right, so you just figure out which one looks the right way after you've rearranged it to where the bigger coefficient is out in front, this alpha term. Again, if you didn't do that, it would still work out. You would just have to with these minus ones. You'd have a negative in there, and you'd have to use the appropriate even and odd function rule for sine and cosine. Sum to product reverses the role. We now start off with addition or subtraction, and we end up with multiplication as that last operator. Right? So we start off with adding trig functions or subtracting trig functions and end up with multiplying them. All right, so once again, I'm going to start off with adding two sines. That's this one right here. So alpha and then a beta. So we add them together and divide by 2, average them. So the very first one I'm going to get is 2 sine. Add these together. So 9 plus 5x. 9x plus 5x is 14x. Divided by 2 is 7x. Okay, so that's another way to say average the two. So the average of 9x and 5x is 7x. And then times, we're changing it to multiplication. The cosine of the difference between the two. So again, 9 minus 5 is 4. And then 4 divided by 2, all right, will give me a 2x. All right, so 2 sine 7x times the cosine of 2x. We start off with plus, we end up with multiplication. All right, for part B, let me switch again. I've got a cosine minus a cosine. So cosine minus a cosine, that's this one right here. And I'm going to get negative 2 times the sine of alpha plus beta over 2. So adding these together, I'll get a 4 plus 3 is 7x. And then 7 divided by 2, I can leave it as 7/2 or write it 7x over 2. All right, and then times another sine, and this time the difference between the two. So alpha is 4x minus 3x is 1x. 1x divided by 2 would just be x over 2. Alright, so that's how we use these formulas. We just identify which one it looks like, alright, and then plug those in there. Because once again we've got subtraction to avoid using those even and odd properties. You would want to make, because again addition is commutative, you'd want to make sure that you switch those around. Subtraction is not commutative, so if you flip these around you're going to get the opposite, so you would need to stick a negative in there. And if you notice with these, if I flip this around and I change this to a negative, alpha and beta are going to switch. They would switch here, alright, and if they switch here, that would be the opposite too. And then that, remember that rule with sine. The sine of negative theta is equal to the opposite of the sine of theta, and it would work itself out. So switching here would create a negative, but that would also switch beta and alpha here, which would create another negative, which would offset it. Okay, so you can switch those around if you want to, and it's going to work out. You just have to, the reason why you would want to is if you ever had a case where you had something like cosine of 3x minus the cosine of 4x. Alright, if you switch that around, if you made it the cosine of 4x minus the cosine of 3x, if you tried to do that to make, and you could, to make this part right here have a positive number inside the sign, you just have to remember that this is only true if you negate it, and then you would have to negate that. You would have to negate that 2 right there to fix it. Okay, so it's a little bit different than it was on the last one, where it was multiplication was commutative. We could rearrange the order however we wanted to. That's not going to be true when we have a minus in front. If we want to flip the order to get the bigger coefficient out in front, we would have to negate the other side to be able to do it. Okay, so just be careful if you're trying to do that. Same technique I was talking about here, to always create a positive input in these trig functions. It's still doable over here to create a positive alpha minus beta and make that always positive. It's just that because subtraction is not commutative, you would have to offset it with a negative sign out front. Alright, let's use one to verify the identity. So I've got subtraction of cosine and addition of sine in the top and bottom, and they have different inputs. So that tells me that I'm going to use the sum to product formulas. I'm going to grab those and bring it over here to this other side so we can see which ones we're going to use. Let me shrink this down a little. So which one applies here? We got cosine minus cosine, so that's going to be the very bottom one here. That's this guy right here. And then we've got sine plus sine, which is this one right here. Okay, now this is what I was talking about before. On the top, this 3x minus cosine 5x, this is bigger than this. Okay, I can leave it this way and it'll all, but I'll have a negative 2 right here. The other option is I can flip it around, and then I would have to drop that negative off. Okay, if I did that, it would fix this to where this is not going to have a negative. Right now, if this is my alpha and this is beta, 3x minus 5x that would occur right here is negative 2. Alright, so we'd have a negative. Sine of a negative is the same thing as sine of the positive, but just the opposite. So if we took that negative away, we could rearrange this and make this alpha and this beta. Alright, we just have to be careful when we use this formula. I want to show you how to do it just as it is on the surface, and then I'm going to show you we got the same thing if we would have flipped that around. So I'm going to call this alpha and beta in both cases. Alright, so I've got cosine of alpha minus cosine beta. I'm going to use this one down here. I got a negative. This is just the top. Negative 2 sine alpha plus beta, so 3x plus 5x. So that's 8x divided by 2, which will be a 4x. Alright, just plugging into this guy right here. and then a sine times a sine of alpha minus beta. Now watch what happens here. 3x minus 5x. The minus is coming from here, not here. It's just the things that are on the inside. Alright, so 3 minus 5 is negative 2x divided by 2, which is just negative x. Alright, so 3 minus 5 is negative 2, or negative 2 divided by 2 is negative x. And then all that is over top of, now I'm going to put the sine of 3x plus sine of 5x into this top formula and simplify. So I'll have a 2 sine alpha plus beta over 2. 3 plus 5 is 8x over 2, which is again a 4x, times the cosine of alpha minus beta over 2. Alpha minus beta over 2 again is 3x minus 5x is negative 2x divided by 2 is negative x. Alright, now let's simplify. Obviously this will cancel. A negative divided by positive is a negative, so we got a negative, and this is sine divided by cosine is tangent of negative x. But this is where we use our odd properties of tangent. Tangent and sine are odd functions. So the tangent, if you remember the odd property, tangent of negative theta is the same thing as the opposite of the tangent of theta. So we got a tangent negative x here. That's the same thing as the opposite of the tangent of positive x. And negative and a negative creates a positive. So we end up with that right-hand side of tangent. Okay, and that's what we're after. Remember, we want to work with just one side at a time with this. Okay, we always want to work with just one side at a time. All right, now when we got to this step right here, we had the negatives. To avoid the negatives, we would have to flip-flop who is alpha and who is beta. And again, it's fine on the bottom because it's addition, and addition's commutative. We can rearrange. But if we did that, what's going to happen on the bottom if I say 5x plus 3x down here? I would have 2 times the sine of alpha plus beta. 5 plus 3 is 8 divided by 2, still 4x, times the cosine. But now alpha minus beta, if I'm calling this alpha, that's 5 minus 3 is positive 2, and positive 2 divided by 2 is just positive x. Okay, so everything's fine there because it's plus, and the order doesn't matter when it's plus. It's this one that we're going to have to be careful with. When I switch this around, this was in front. Okay, if I'm switching it around, calling this alpha, I'm moving it. I'm doing this. I'm writing negative cosine 5x plus the cosine of 3x. All right, I'm switching it around to make this lead off. Okay, but I don't have one that leads with a negative. So what do? I'm going to multiply by negative 1. And when I do that, I will change this to the cosine of 5x minus the cosine of 3x. Okay, so I multiplied this by negative 1, and I've created one that looks like this one again. Okay, but since I multiplied by negative 1 to make it look like this, it's really the opposite of this. So I need to multiply this side by negative 1, which will just make that a plus. So I end up with a 2 sine, this is alpha plus beta over 2, same as it was before, so this will be a 4x. Alpha minus beta, now we're using this, so it's positive 5 minus 3 is positive 2, divided by 2 will be cosine of 1x. And it's positive again. Oops, sorry, that should be a sine. It's positive again, so I don't have to worry about odd properties. Okay, so it's not tremendously easier, but now I just end up with tangent. I don't have to worry about the odd property to give me tangent. I just have to flip this around, which is going to create an opposite sign here. All right, so that's an option that you have anytime you ever have subtraction and you're using these identities and you're using the ones that have subtraction. If the second term that's being subtracted, if it has a bigger coefficient than the first, you can flip it around. Right? You can flip it around and use the same identity. It's just the other side's going to change. So if this had been sine 3x minus sine 5x. I could still use this one and make this, make it this lead off, so we end up with a positive here. It's just that would become a negative 2 if that's the case. All right, so do it however you want to do it. If you're comfortable with the even and odd properties of sine and tangent and cosine, then by all means go ahead. But to avoid that, you can always make this, force it to kind of lead off by flipping it around. But if you do, change the other side to its opposite.